Welcome back. For those of you guys that don't know me, I'm Professor Silva. Started in the field networking about 20 years ago, incorporated Archon 1 about 8 years ago, and it's a field that I'm extremely passionate about. I prepared a series of videos here for us to understand a little more about the basics of computer networking and what it takes to get into the field, answer some common questions. So let's jump into the material. So first off, you have to understand how computer networks work, right? At the top level, you've got your applications. These are things like Chrome, Firefox, Outlook, Internet Explorer, if you use Internet Explorer, or Edge, or any of these other top level applications. They somehow connect data to other servers around the world, right? And they receive data and they transmit data. Now, on the very base layer, you've got physical cables, right? So you have like Cat5 cable, you've got coaxial cable, you actually have Wi-Fi, right? No cables, just wireless frequencies. You have fiber optic cables, and there's a bunch of other what are called transmission media that are used to transmit at the bottom. So somewhere between the applications that you use at the top level and the actual physical cables that you use to transport those signals at the bottom are what are called layers, and these are called the OSI layers for Open Standards Interconnect. And the OSI layers actually represent 7 unique states, 7 unique layers of how data gets from one place to the other. So over here you've got your application layer, your presentation layer, session layer, transport layer, network layer, data link layer, and your physical layer. Let's take a look at what each one of these does. I'd like to start from the bottom up actually. So down here at the physical layer, these are the cables and physical materials that transport your data. So these are things like Cat5e cables, coaxial cables, Wi-Fi frequencies, fiber optic cables. Basic data encoding is done here, but this is really just in the form of electrical impulses, for example, if it's on a Cat5 cable, or if it's a fiber optic cable, this is a light going on and off, or if it's radio frequency, it's modulation in that frequency. So there really isn't a lot of intelligence, so to speak, that goes on at this particular level. This is really just around physical connectivity, like end to end, like click in a network cable or associate with a Wi-Fi network type connectivity. On the second layer, you've got something called the data link layer. Now, the data link layer is particularly interesting because even though the physical layer is responsible for this end-to-end physical connectivity, the data link layer is responsible for actually making what are called frames. Now, frames are the most basic unit of data in computer networking, as far as I'm concerned. This could be debated. But as far as the data being translated out of the physical realm and into something more conceptual, like something more logical, like a 1 or a 0, that happens here on the data link layer. So the data link layer is responsible for creating what are called frames. And a frame is basically a multi-part bit sequence that we'll go into in a little more detail later. But basically it lines up data from the point of origination to where it's supposed to go, contains the data, and then there's a check sequence at the end. There's a little more detail to that, but again, we'll break that out. Again, so just on a high level, the data link layer is responsible for producing something called a frame, which is where data gets switched back and forth on local area networks. Now, although the data link layer is really useful for sharing data from within a local network, if you want data to leave the local network and go somewhere else, you need to identify a way to get it onto that remote network. And that's actually what happens on the network layer. So the network layer is responsible for what's called routing, and specifically routing packets. So you notice that on layer 2, I referred to the data there as a frame. On layer 3, when data is prepared, it's actually called a packet. And packets get routed from one place to the next based on the destination network and the source network that it's coming to. Routing is a whole separate field. It's a completely different topic, so I'm not going to go into a lot of that right now in detail. But suffice to say right now that the data link layer takes care of communication just within your local network, and the network layer takes care of more of global routing, if you will. Although you can route traffic locally. So again, hold that thought. We'll get into that later. Just consider layer 2 switch local for routing network traffic over layer 3. That's going to go out further across the public internet. Layer 4 is responsible for what's called the transport layer. Actually, the name of it is the transport layer. The transport layer is responsible for making sure that when traffic gets sent, that it actually arrives. There are two major protocols that are used on the transport layer. One is called TCP, and the other one is called UDP. TCP is what's called a connection-oriented protocol, and UDP is what's called a connectionless protocol. So for example, with a connection-oriented protocol, if you're to connect out to a remote site, and let's say you want to post some information or you need positive confirmation that your traffic came back, you would put that up in TCP, right? You'd create that connection over TCP. And there's a way that that happens. It's called the TCP three-way handshake, which we'll go into a little bit later. The UDP protocol, on the other hand, is a slightly higher bandwidth protocol, meaning that it's connectionless, so you're not requesting confirmation of receipt of every single segment. And a segment is what data is referred to on the transport layer. So you might say, well, why would I never need confirmation of data that I sent? Like, doesn't that seem silly? Actually, any type of real-time application of data transmission, so things like video conferencing or voice over IP or streaming internet, radio, anything like that that has to do with some type of data that you don't necessarily need confirmation for because you can't rebuild it, like anything time sensitive. If you think about it, you can't go back in time and insert traffic back behind where a phone call started to reconstruct that conversation, right? So that would be a real-time conversation. So UDP is used in a lot of those real-time connections where you prefer the amount of data over the actual quality of the data that's received. The top three layers here are called session, presentation, and application. And you notice here that I have them listed in green. So the session, presentation, and application layers are pretty similar. There are some key differences. I mean, technically, the session layer is used to synchronize and send data to logical ports. Presentation layer is used for things like encryption and decryption if it's necessary. And the application layer is used for the actual presentation of the application itself. Sorry to use that word twice, but you can think of things like Microsoft Outlook sitting on the very top. That would be on the application layer. Encryption algorithms, things like AES or asynchronous encryption, decryption would happen on the presentation layer. So anyway, so this is basically it. You've got your 7 layers here at the very bottom. You've got your physical layer, data link, network, transport, session, presentation, and application. And at any given point when you transmit data, if you start in the application layer, it actually goes all the way down through every one of these layers until it hits the last one, which is the physical layer, goes over some type of physical media, and then it comes back up the stack again and reaches its target destination. So that's a very basic introduction to the OSI networking model. And in future videos here, we're going to cover each one of these topics in a lot greater detail. So send me a comment below or let me know if you have any other questions and we'll cover it in more detail. But I hope this has been helpful for you and I look forward to seeing you soon.